Let's discuss several electrical code violations stemming from an incorrect installation of a landscape lighting circuit. The issues relate to tapping into an air conditioning disconnect, using a neutral as a ground, and failing to properly ground an outlet. The first violation to address is National Electrical Code Section 408.4a, which states that appliances should be connected to a circuit ahead of the service disconnecting means and the overcurrent device protecting the circuit. In this specific scenario, the air conditioning disconnect is not a service disconnecting means for the landscape lighting circuit. This means that it's inappropriate to tap into the load side of the air conditioning disconnect to feed the lighting circuit. This is because the air conditioning disconnect is intended to isolate the air conditioning unit for maintenance and safety, not to serve as a junction point for unrelated circuits like landscape lighting. The second violation concerns National Electrical Code Section 300.3b, which covers the continuity and bonding of equipment grounding conductors. A key provision within this section is that the neutral conductor cannot be used as an equipment grounding conductor. In the described installation, a 6/3 with ground cable was used, and the neutral conductor was incorrectly used as the equipment grounding conductor for the lighting circuit. This is a dangerous practice because the neutral conductor is intended to carry current back to the source, and if it's also used as a ground, it can create a potential shock hazard. Furthermore, if the neutral connection becomes loose or disconnected, any equipment connected to the ground via the neutral could become energized, posing a significant risk of electrical shock. The third violation involves National Electrical Code Section 210.7d7, which mandates that every outlet shall be grounded. In the described scenario, the second light fixture was not properly grounded, which presents a safety hazard. Grounding provides a low impedance path for fault current to return to the source, allowing the overcurrent protection device like a circuit breaker or fuse to trip and de-energize the circuit in the event of a fault. Without proper grounding, a fault could cause the metal parts of the light fixture to become energized, potentially shocking anyone who comes into contact with it. Now let's examine why the tap rule, as outlined in National Electrical Code Section 240.15, does not apply in this particular situation. The tap rule allows for the use of smaller conductors to tap off of a larger feeder under certain conditions, mainly to reduce voltage drop or for specific equipment needs. However, a critical requirement for the tap rule to apply is that the tap must be taken from the supply side, also known as the line side, of the overcurrent protection device. In this case, the tap was not taken from the supply side of the air conditioning disconnect. Instead, it was taken from the load side of the air conditioning disconnect, which is a direct violation of National Electrical Code Section 408.4a, as previously mentioned. This fundamental error disqualifies the installation from being considered a valid tap under the National Electrical Code. In addition to the code violations, there are several additional concerns with this installation. Firstly, the use of a makeshift Fusitron fuse holder, specifically an Eagle Rubber 660-watt lamp holder, is not an approved method for providing overcurrent protection. This type of lamp holder is designed for low wattage lighting applications and is not intended or rated for use as a fuse holder in a branch circuit. It lacks the necessary safety features and testing certifications to ensure reliable overcurrent protection. Secondly, the GFCI receptacle, while providing ground fault protection, is not a suitable overcurrent protection device for the lighting circuit. GFCI receptacles are designed to protect against ground faults, which are different from overcurrent conditions like short circuits or overloads. Overcurrent protection requires a device such as a circuit breaker or fuse that is properly sized to protect the circuit conductors from excessive current. The GFCI receptacle itself does not provide this level of protection. Thirdly, the 6/3 with ground cable used for the lighting circuit is not the correct type of cable for this application. A 6/3 cable is typically used for higher amperage circuits, such as those serving electric ranges or dryers. For standard landscape lighting circuit, a smaller gauge cable, such as a 14/3 with ground cable, would be more appropriate. The use of an oversized cable not only increases the cost of the installation, but also may make it more difficult to make proper connections in the junction boxes and fixtures. To summarize, the installation described is riddled with code violations and unsafe practices. Tapping into the load side of the air conditioning disconnect, using the neutral as a ground, failing to ground the second light fixture, and using a makeshift fuse holder all violate specific sections of the National Electrical Code and create potential safety hazards. Furthermore, the tap rule does not apply in this case because the tap was taken from the load side of the air conditioning disconnect. To rectify these issues, the entire lighting circuit needs to be re-evaluated and rewired in accordance with the National Electrical Code. Firstly, the circuit should be fed from a dedicated circuit breaker in the electrical panel, ensuring that it's properly protected by an overcurrent device. Secondly, a separate equipment grounding conductor must be installed to ground all metal parts of the lighting fixtures and junction boxes. Thirdly, the correct type and size of cable, such as a 14/3 with ground, should be used for the wiring. And finally, all connections must be made in approved junction boxes and using appropriate wiring methods. By addressing these issues and adhering to the National Electrical Code, the landscape lighting circuit can be made safe and compliant. Remember, electrical work should always be performed by a qualified and licensed electrician to ensure safety and compliance with all applicable codes and regulations. Ignoring these guidelines can lead to electrical shock, fire hazards, and property damage.